Um, in the previous video, we said how to find eigenvectors. You're in effect finding a basis for the null space of this equation. We did an example. It was just a 2 by 2 case, and the eigenvalues were distinct. We got two eigenvectors, and we also proved that when this is the case, when the eigenvalues are distinct, the corresponding eigenvectors will be linearly independent. We did this little proof in the previous video. Let's start looking at repeated eigenvalues. Okay, here's our A. We're going to subtract lambda from all the diagonal elements. There we go. And then takes this determinant. I'll expand by this first column because it's got two zeros. So I'll get 1 minus lambda times this sub determinant, which will be 2 minus lambda squared minus 1. All right, multiply that out. Well, multiply this inner part out. I get this, and I can factor that. Factor the whole thing, and what do I get? There's an eigenvector equals 1, another eigenvalue equals 1, another eigenvalue equals 1, and 3. So I have a repeated eigenvalue here. So let's see what happens here. So there's my A, there's my eigenvalues. Let's do the distinct one first. Lambda equals 3. 1 minus 3 is minus 2. 2 minus 3 is minus 1. All right, the rest stays the same. But with a little bit of row operations. There's a pivot, there's my row of all zeros. Remember, you better get a row of all zeros. And by the way, you don't have to put this right column there. I am just doing it to make it explicit, but you know these are always homogeneous equations. So the right column is always going to be 0. You don't have to write that if you don't want to. So K3 is going to be my free variable. What's this top thing telling me? K1 minus 3K2 equals 0, or K1 equals 3K2. This tells me K2 minus K3 equals 0, or K2 equals K3. So if I set K3 to 1, there's the 1. That means K2 equals 1, and that means K1 equals 3. So there is my eigenvector corresponding to that eigenvalue. Now let's do the repeated one, which was 1. So I'll get a 0, 1, 1. Start doing my row ops. Takes me 2 steps. I get this. Pivot, pivot. So K1 is my free variable in this case. The other two just tell me that K2 equals 0 and K3 equals 0. So my one and only eigenvector corresponding to this repeated eigenvalue is 1, 0, 0. And I only get one. I do not get 2 eigenvectors for this double or repeated eigenvalue. Until if I get the bottom line. Let me stop right there. So we did one example of a repeated eigenvalue. It's repeated twice, and we only got one eigenvector corresponding to that repeated eigenvalue. We'll do other cases in another video.